Hello, everyone. I'm here to talk about smart embedded vision on PolarFire SoC FPGA. So, smart embedded vision essentially is imaging and video applications, image processing and video processing that we've been working on, including AIML. My name is Krishnakumar. I'm a senior product marketing manager at the FPGA business unit at Microchip. I go by the name KK, and so you have KK at microchip.com. So easy enough. So let me get started. So I'm pretty confident that you're familiar with Microchip technology. We are a total system solutions company. So essentially, if you are developing any electronic product, chances are you've come across Microchip. Chances are you're using a Microchip component on your system, or you can use one. We have various products in our portfolio. And in this session, I'm particularly going to be focusing on the PolarFire SoC FPGA, which is our RISC-V based SoC FPGA platform. So PolarFire SoC in Smart Embedded Vision. So what you see here is a block diagram of our SoC FPGA. It's based on a 5-core, 64-bit RISC-V processor subsystem. And all the light blue blocks you see here, they're all hardened IPs available on the device. So we have high-speed interfaces, dual gigabit Ethernet. We have PCIe interface, and so on. And right at the bottom here, you'd find our high-speed IOs and transceivers. We have up to 1.6 Gbps IOs and up to 12.5 Gbps transceivers on it. And right in between, all the dark blue blocks are part of our FPGA. So these are soft IPs that you can port on our FPGA fabric and enable a host of applications. So in the context of this presentation, I'm particularly focusing on embedded imaging and video applications, including AI ML. So essentially, what you have with an SoC FPGA is an extremely capable microprocessor subsystem that can be extended beyond its capabilities using the FPGA fabric. So you want an HDMI interface? Yeah, we have it in our soft IP portfolio. You can put it on the fabric and extend the functionality. You want an LVDS interface. You want I don't know, a 10 gig Ethernet interface, name it, and you get ported on our fabric, and you can extend the functionality. Also, if you are, let's say, more familiar with embedded development and not too familiar with FPGA development, we also have a tool for high-level synthesis. So you can develop your C or C++ code, your embedded development code, and we're using our HLS compiler. You can translate it or compile it over to RTL and even program the fabric. So even for those who are not familiar with FPGA development and programming, we have solutions for you. So as an SoC FPGA provider, what differentiates us? So our core strengths, or like the way I'd like to call it, are the three important things that forms our DNA. That would be low power, security, and reliability. So for instance, let's say in an embedded vision application, you'd find that our FPGAs are 3 to 8 watts lower power consuming than what's available from our competitors. So what does that mean? So it enables us to be used in battery operated systems. You don't need clunky heat sinks or fans in your systems, so you can really design sleek solutions. Also, we enable really small form factor design, so you can really make sweet, sleek systems using our FPGAs and SoC FPGAs. On top of it, we are the most popular FPGA company out there for aerospace and defense applications. So they really care about reliability and security, and that's some of our core strengths as well. So if you want to have more discussions about our security and reliability capabilities, you can catch me out here, and we can have much more detailed conversation. And coming to our FPGA fabric. So, like I said, we are talking about AI/ML applications, and I'll show you some of the demos we have on AI/ML. And our FPGA fabric is architected to have a 4-input LUT. So, typically in most AI/ML applications, you would be doing a lot of matrix multiplications. And our fabric is ideally suited to design the most efficient CNNs in them. So that's what makes our FPGA design much more unique. So let me go a little bit deeper into what we have on the AI/ML flow. So our AI/ML solution is called the Vector Blocks SDK. Right, so we enable you to use our SDK. You can port over your own model using our SDK and port the solution over to our FPGA fabric. We support the vast majority of the frameworks available out there. So chances are you're using one of these. And you can just download a license for this from our website and port the solution over to the FPGA fabric. In fact, we also have a vector blocks simulator. So even before you ever touch one of our FPGA boards, you can just use the vector blocks simulator and have a sense of what kind of performance you're going to get. Right, so the entry barrier is really low. You can get started with this pretty quickly. And for our recommendation is that if you have your application that's going to need less than 300 GOPS of performance, chances are our FPGAs would be really ideal for you. I also want to talk about how we perform versus competition, because there are AI/ML solutions out there from quite a few players. So what you see here is a spreadsheet, well, of course, with quite a few numbers and a bar chart to the right. So let me get your attention to the bar chart. So what you see here, the first two bars you see out here are the power consumption figures of some of our competitors. The dots you see on top are the performance or GOPS of the competitive solutions. So the first bar, for instance, you get a 333 giga operations per second of performance, while it consumes about 4 watts of power. Okay, and the next one is 166 giga operations per second, while it consumes 2.7 watts of power. And the next 3 little bars that you see on the right, those are from our solution, the vector blocks running on our PolarFire SoC FPGA. All right, so we have the V1000, V500, and V250. So based on the performance requirements of your system, you can pick one and select. So for a sense of comparison right here, so let's look at the V1000. You'd find that V1000 gives a performance of 279 giga operations per second while consuming 1.3 watts. So in terms of performance, it's similar to what's offered by the first bar, pretty close, about 80% of that. And it consumes 1/3 the power, in fact, less than 1/3 the power. So that's where we excel. So our AI/ML solutions are available for the edge application. So they are available for the edge application. These are systems that can run without heat sinks or fans, and it could even be possible to be used in battery-operated conditions. So that's where we excel, and that's where most of our customers use our solutions. So how do we enable these solutions for you? So we have our hardware, which is tailor-made for imaging and video applications. We call it the PolarFire SoC SEV kit or the video kit. So what you see here is actually tailor-made for imaging applications. You will find 2 4K cameras built into this hardware. It has a MIPI CSI interface. We have dual HDMI interface. One is an HDMI in and an HDMI out. We have DisplayPort interfaces, MIPI DSI interfaces, dual gigabit Ethernet interfaces, and so on. And we also have an FMC connector. So essentially, you can plug on any other FMC daughter card you want to it and extend the capabilities of this hardware. Right? So this is available for you. In fact, you can see this hardware in the Microchip booth, and we have a few demos out there. So coming to demos. So So these are some of the demos we already have available on the PolarFire SoC FPGA focused on video and imaging applications. So let me go over a couple of them to give you a sense of what we've been working on. So for instance, this one, it's a simple design. It takes in a camera interface, input on a MIPI CSI interface. It does an H.264 encode and transmits it over a gigabit Ethernet. Mind you, the way we work is that the most efficient path is to use the FPGA fabric to do the heavy lifting in terms of image processing, video processing, and we have the MSS right across an AMBA AXI interface, from which you can communicate, control, and interface with the FPGA data path. So that's one simple design. We do have an edge detection using OpenVX. We also have a face detection solution. What you see here is this is a video. So essentially, you can either have a MIPI CSI interface going through data flowing through the fabric, or an HDMI input. And you have our core vector blocks IP that does the image inferencing algorithm, and it transmits out over to the HDMI interface again. Again, here, there are some level of communications happening between the microprocessor subsystem, which is the RISC-V based processing subsystem, and which controls and communicates with the core vector blocks IP. So we also have our own HLS solution, like I said before. So you can, in fact, compare the performance or image processing, video processing performance on the microprocessor subsystem versus an accelerated solution on the fabric. So in fact, this demo is actually available at our booth right now. So if you're interested, you can go take a look. We also have a similar solution, essentially enabled by the same vector blocks IP. And okay, man, there you go. So this is a license plate detection, a license plate recognition demo. All right. So a similar flow, as I said before, with the face detection, but the functionality quite different. This is a demo available with us as well. So essentially, what we do with our solutions is to enable you with our hardware, and all these solutions are available from Microchip for you to evaluate and take it forward in your designs. So these are all solutions from Microchip. I also want to take a moment to talk about our ecosystem. So we've been working with a whole range of third-party organizations. We call it the MiFi ecosystem. And if you're, let's say, your requirement don't match completely with what's offered by Microchip, we have a host of third-party organizations who are part of the MiFi ecosystem. You need a different development tool. We have a range of them available from our ecosystem partners. You want to work on a different operating system or an RTOS, we have those available as well. Similarly, you want, if you're not comfortable designing your own products, or you need help with them, we have a range of design service organizations who have worked on our hardware, our tools, and so on. So they'll be able to help you out. Or similarly, hardware. You want to develop help with developing your own custom hardware. We have partners doing that as well. All right. So PolarFire SoC FPGA is one of the only SoC FPGAs based on RISC-V that's going to be really available for at least the next 20 years. So I hope you can take a closer look come to our booth, take a closer look at our solutions, and if you have any questions, I'd be happy to answer them.